So they give us pressures, but we have a K sub C value. So our first step is to switch from K sub C to K sub P. And so the equation for that is K sub P equals K sub C times RT to the delta N. And so we have our K sub C value already, and R is going to be the constant 0.08206 liters atmosphere per mole Kelvin. And then T is just going to be 376 Kelvin. And then delta N is found by doing the moles of gaseous products minus the moles of gaseous reactants. And so in this situation, it's going to be 2 plus 1 minus 1. So that gives us 2. So now we have to plug all of these values into our K sub P equation. So K sub P equals 2.87 times 10 to the negative 10th times 0.08206 times 376 quantity squared. And so this will come out to equal 2.73 times 10 to the negative 7th. Okay, so now that we have our K sub P, we can use this in an ice table to figure out the equilibrium pressures of X gas and M gas. So we rewrite our equation. And so our initial pressure of X sub 2 M gas is given in torr, but our ice table requires that it be in atmospheres. So first we need to change it from torr, 578 torr, and there's 1 atmosphere per 760 torr. And that gives us 0.761 atmospheres. So we can plug that into this slot. And we just assume that X is 0 and M is 0. And then from the balanced equation, we see that the change is just plus X for that, plus 2X for X gas, and then minus X for X sub 2 M gas. And so equilibrium is 0.76 minus X, 761 minus X, 0.2X, 2X, and just X. And so we take our K sub P value and set it equal to X times 2X quantity squared over 0.761 minus X. And because our K sub P value seems to be sufficiently small enough, we can do our S a small approximation. And so our K sub P is equal to 4x cubed over 0.761. And so when we multiply it by 0.761, then divide by 4, and then take the cubed root, we get that x equals 0.00373 atmospheres. And we know that this is the partial pressure of our M gas, but to find the partial pressure of our X gas, we need to multiply this by 2. So we get that our partial pressure of X gas is 0.00746 atmospheres. And since the problem gave us torrs originally, we should probably convert back to torrs. And so it's a simple, you just multiply it by 760 torr per atmosphere. And we end up with our partial pressure equilibrium in gas equaling 2.83 torr, and our partial pressure of X gas at equilibrium equals 5.67 torr.